Hello, I'm Mike from GroveStreams. In this video, I discuss the GroveStreams structured query language. I will go over why we chose the SQL standard, where GSSQL is used in GroveStreams, our specific language conventions and role-based security, our time series extensions. We'll go over some examples, queryable tables, performance tips, and the future of GSSQL. I will not go over the SQL language. The web is full of SQL information and examples that do a much better job explaining SQL than I ever could. I will focus on the things that make us different. Why did we implement a query feature, and why did we choose SQL? You're streaming a lot of data into your GroveStreams organization. Now you need answers to more complex questions. Over the last 50 years, SQL has become the de facto tool used by organizations around the world to do just that. That's why we designed our own structured query language from scratch based on the SQL standard, but with extensions to make it easier to use for time series data. Basing GSSQL on the SQL standard allows our users to leverage the large amount of SQL knowledge on the web, along with being compatible with thousands of applications that work with SQL, such as business intelligence and reporting applications. If you're an enterprise analytics platform, supporting SQL is almost mandatory nowadays. Our current implementation of SQL only supports retrieval of result sets. It does not support deleting, inserting, or updating. Where is GSSQL used in GroveStreams? I'll show you. But first, an index table is needed for GSSQL to work. The index table is responsible for making query statements less complex by requiring less joins, and it makes queries faster by creating some column indexes. Go into your organization and select Admin, Organization, General Settings, and select the Query tab. If you're not seeing the Query tab, then your pricing plan does not include GSSQL, or your administrator has not granted you query rights within the organization. Click the Query Index Table button to create the table. This only needs to be done once. Queries can now be edited and run. Let's do this now. Select Admin, GS Language Query Tester. A default query will appear that returns all stream names in the root folder. I'll just run that one. Use the display filter to limit what is shown in the grid. You can select cells and use Control-C to copy results to the clipboard. And results can be exported to CSV files. The selected time zone will be used if an SQL function has an optional time zone parameter and one wasn't included. The time zone will also be used if a GS cycle is included in a query. Queries can be defined and saved along with their result sets within the tools repository. Save queries allow for long-running unattended queries. They save results in the store to allow for fast retrieval of large result sets. They can be scheduled to run for things like daily and monthly reports. Results can be automatically emailed. Let's create one and go over it. Select the Tools tab, click on Queries, right-click and create a new query. I'll give it a name, Demo Query. Select the SQL tab and enter the SQL statement. Now click the Update Cache button to run the query. The result set is now saved in the store cache. Click on the Cache Information tab to view information related to the last run. Click on the Last Error tab to view any errors from the last run of the query. Query errors will also be inserted as system notifications. Select the Schedule tab to configure a schedule. Schedules can be repeatable. The query results can be emailed after each scheduled run. The saved query can now be used within a dashboard. I'll quickly demo that by dropping a GS SQL table widget onto the dashboard and selecting the query we just created. Drag the query onto the new widget. This widget now displays the saved query's cached result. We can instead specify a query to run whenever the dashboard is displayed. To do this, select the GSSQL tab, change it from Query Cache to SQL Statement, and enter the SQL statement that will be run when the dashboard is opened. You can also drop a graph right onto the dashboard. When this is done, they will automatically link to the table. Another place GSSQL can be used is in a stream group definition. Stream groups define a set of similar streams. Groups can be used in dashboards to dynamically pick up new streams and display them. Let's create a stream group that contains all PSI streams. Change the stream selection type to Select by Query String. The query select statement must return the stream UID and the component UID. This query returns all of the PSI streams in the organization. The stream group cache can now be scheduled to update within a scheduled runnable, or we can update it manually, which I'll do now. All of these streams now belong to this group. The last place GSSQL queries can be used is from our HTTP API. The GSSQL grammar implementation is based off of SQLite's implementation. We've implemented most of SQLite's grammar, including inline views and joins and compound operators. I've used several SQL implementations in my past career, so when I designed GSSQL, I enforced conventions that I thought would make it easier to use. These GroveStreams specific conventions are listed on our SQL page. Most items are case insensitive, including table names, column names, functions, and other reserved words. Comments are supported in SQL statements. Joining strings together can be done with the plus operator. Use and or two ampersands in where conditions. Use or double pipes. Date times are represented by epoch milliseconds under the covers, just like the rest of GroveStreams. Date time formatting functions can be used to make them readable. Stream data in GSSQL are referred to as samples or the samples column. The samples column has time series parameters that can be included. I'll go over those shortly as they're the heart of GSSQL. Make sure you read the null convention section. It's important to understand how nulls are treated by GSSQL, which is how most SQL implementations treat nulls. GSSQL respects GroveStreams content access security. The result sets will only contain items that the calling user has read permissions for. For example, if the calling user does not have read rights to a certain component folder, no items in that folder will be returned in the result set. The number of data types supported have been limited to keep things simple. GSSQL will perform automatic data type conversions from stream types to these supported types: double, long, string, boolean, and big decimal. Let's go over the GSSQL time series sample extensions. This is what makes GSSQL powerful, fast, and easy to use. The sample parameters can be found on our support pages by selecting grammar and then selecting sample parameters. Let's quickly go over each. First, the range parameter. The range parameter is used to filter samples by time. It has a start date time, which is inclusive, and end date time, which is exclusive, and is represented by the SD and ED parameters. The SD and ED parameters can be derived using other parameters. Let's look at a few examples to better understand the range parameter. No parameters are used for this example. It will return all of the stream samples by using the stream start date and end date for the range. This query uses the fixed time range in the ISO 8601 standard format. This one uses a fixed time range defined in the query, but in epoch milliseconds. The next set of queries derive the range's SD and ED parameters. This query returns the last day from the current date time. This one returns samples from now to 1 year in the future. This one returns the last day from the stream's tail. This query returns an hour of data from 2 hours ago to 1 hour ago. This query uses the month cycle, which is defined within GroveStreams. It uses the cycle with the current time to derive the range for the current month. This one returns the previous month. This query returns the last 100 samples. And this query returns the last 100 samples from 1 week ago. As you can see, the range parameter has a lot of flexibility and is easy to use. GroveStreams time filters can be used as a sample parameter like this. This is an example of a time filter being used with a range parameter. It returns all samples with Saturday or Sunday times over the last 4 weeks. Rollups and statistics can also be used within the sample request. This query returns all samples aggregated into month intervals. Samples are aggregated using the sum statistic. Since rollup statistics are pre-calculated and saved in GroveStreams, these types of queries are extremely fast. This query uses the day cycle to return all daily maximums along with the time each peak occurred. The gap fill parameter allows gaps to be filled within result sets. This query returns all interval samples with gaps set to the string off. This final example demonstrates many parameters used at the same time. It returns all hourly interval samples with weekend afternoon hour gaps filled for the current year. That's a mouthful, but you get how our sample extensions make SQL much easier to use with time series data. Let's take a minute to talk about metadata. Metadata can be associated with components and streams within GroveStreams. The metadata can be used in a GSSQL query for filtering, sorting, and grouping. What does that mean? Okay, this is important. I'm going to demonstrate it. I've modeled some components with streams that represent metadata. The metadata is represented as another stream. They can be regular, interval, or point streams. I've made them regular streams so that changes to the metadata over time are tracked. The component has a stream for its country, its state, its city. I also included a model and serial number streams. We can now query for the stream's data using the country, state, and city to filter out certain components, or maybe we want to sort and group by those values, or maybe display them in a GS dashboard's pivot grid and let the user slice and dice and sum things. A metadata type query uses inner joins to combine each subquery result set based on the component UID. This is an example of using the metadata streams along with inner joins to filter results. It's returning only compressors for Minneapolis and Chicago. I highly recommend learning SQL inner joins to fully understand what this query is doing. It's not as complex as it looks. Let's go over the tables that can be used in GSSQL queries. Today, we only have one table, and that's the stream table. In the future, we might have more tables that will allow our users to query over things like notifications or organization users. For now, we only allow component and stream data to be queried. The stream table is one big table. In reality, there are two tables being used: the index table, which is the one we created at the start of this video, and the stream table. The stream samples table is the production stream data table. Both tables have the latest data in them so that queries return the latest changes as they're happening. GSSQL will automatically join these two tables for queries involving columns from both. We designed it that way so that our users don't have to do complex joins in their SQL statements. I'm only mentioning this design because sometimes SQL errors will make mention of the two tables, which could confuse our users. Next, I want to discuss performance. Our SQL engine runs a query simultaneously across all of our store servers at the same time. This is known as parallel processing and makes queries much faster. If you're querying over hundreds of thousands of streams, things could slow down. Here are a couple of performance tips. The stream UID and ID columns are indexed for quick lookups. Try and use the stream ID column in the where clauses as much as possible instead of the stream name. Ors and string wildcards in the where clause force the SQL engine to scan every row and should only be used when needed. Sorting and grouping require all rows to be in memory on our servers. A query will be terminated if it is consuming too much memory. What's next for GSSQL? Well, some things I'm personally thinking about: handling the sorting of billions of rows without hitting the memory constraint, allowing users to index other table columns, implementing SQL insert, update, and delete, or how about deriving a stream from a GSSQL query? I really like that one. We're customer driven when it comes to adding rich features. If there's something your solution needs, drop a comment on the forum or send us an email. In this video, we discussed the GroveStreams Structured Query Language, GSSQL. We went over why we chose the SQL standard, where it is used in GroveStreams, and our conventions and extensions that make querying our streams fast and easy. Thanks for watching.